thank you everyone for taking the time to join us today. As Molly mentioned, my name is Chris Harding. I'm a solutions engineer here at Epsagon, where we provide a trace-centric observability platform that's primarily tailored to modern microservice environments. All right, great. So thanks again for joining us. Our session today on visualizing and analyzing APIs and microservices in distributed environments. All right, let's dive right in. So what are we going to be talking about today? In broad strokes, first we're going to talk about the rise of microservices, really looking at how we got to where we are today with this paradigm shift from monoliths into more microservice-oriented architectures. We'll look at how that that new paradigm clearly has benefits, but it also brings new challenges, particularly related to troubleshooting these highly distributed environments. And then lastly, we'll take a look at this idea of tracing and how that fits into the overall equation. All right, so let's start by taking a step back and really, again, looking at how we got to where we are today. And so I think you can make a good argument that March 19th, 2006 was really a pivotal day in ushering in this this new era of software development. And so for any tech trivia masters out there, you'll probably recognize that as the day that AWS was launched. And AWS was an absolute game changer, right? An organization no longer had to own bare metal servers. They no longer had to put engineers in data centers. And so it really changed the way in which we develop these applications. Now, it didn't necessarily, come out of the door as gangbusters. It took a little bit of time, but particularly during the Great Recession, companies started recognizing the value of no longer having to own that physical infrastructure and be responsible for it. And it's during that period where we saw a lot of these, now really large SaaS companies come into existence, where they were really focusing on creating APIs that allowed other technology companies to no longer worry about specific business processes, right? So like a company like Stripe with payments, a company like Auth0 around user authentication, even database technologies have become highly commoditized and used in these microservice architectures. And now we've evolved to a place where largely a lot of the infrastructure itself is no longer within your control, right? Things like AWS Lambda and functions as a service, things like Docker and Kubernetes that are really orchestrating these payloads. And so that evolution, went hand in hand with this rise of microservices. And so, everyone on the call here is probably at some stage of this journey, whether that's really early in the game or, fully hosted in the cloud. But this is a journey that we see our customers, taking all the time. And it's because it does have a lot of benefits, right? Particularly around things like developer velocity, being able to release new features into a microservice in a way that wasn't really feasible on those monoliths. But of course, that benefit does come with a drawback. And that drawback is that it now becomes extremely hard to monitor and troubleshoot these highly distributed environments. So what do I mean by that, right? I mean, the number one challenge that you're going to have is when you have these highly distributed environments, you might have tens, hundreds, thousands of different microservices. You might be leveraging things like messaging queues or managed databases or talking to external APIs. It can be very difficult when something breaks to know where that break took place, which of those thousands of services was ultimately responsible. It becomes a real challenge to identify that. You may have logs, you may have metrics, they may be spread out all over the place. It's very hard to correlate those data between any two given services. And even if you have those, do you really have all of the information that you need? You have to be sure that if you're working with logs, your engineers log the right information. You don't have access necessarily to that payload information as an example, which is going to be really important, particularly in these microservice environments. Let's look at what that troubleshooting workflow, what that process looks like using some of the traditional tools out there. So of course, first, the problem arrives, right? You receive some sort of notification. In this case, one of our Lambdas is throwing an error. But how do we really know that it's the Lambda itself that's having problems? Right? How do we know it's not, for example, whatever's triggering, whatever's calling that Lambda? How do we know it's not sending a malformed payload? Those are the sort of questions that become really difficult to answer and require you to do that sort of correlation. And traditionally, that's done using logs, right? And so all the engineers on the call here can certainly appreciate this process, right, of having to dig through tens, hundreds, thousands of log lines to try to figure it out and find that needle in a haystack. And it only becomes more difficult when these logs, when you have logs for each of the services that you're using. What you end up with is largely, logs everywhere. And, as someone who spent a number of years as a full-time engineer working at a large company making this transition, I can certainly appreciate the pain. And I sort of break out into cold sweats just thinking about having to go through all those logs to figure out what's going on. All right, so something's missing in these modern environments. How do we correlate between things like metrics and logs? How do we correlate between those data amongst a number of different services? And how do we find that where when something goes wrong, right? Largely metrics tell us what. We know from metrics that something is broken. The logs tell us why once we find the right information. But how do we figure out that where? And so that's where distributed tracing is going to come in. All right, so if you're not familiar at a high level, what is distributed tracing? A trace tells the story of a transaction as it propagates through one of these distributed systems. What's really nice is that because distributed tracing is going to connect every piece and have every request within that transaction, it really allows you to step through at each service, at each node, at each resource, and truly understand what's going on under the hood. Now, where did tracing come from? Largely born out of Google over a decade ago, as they were, very much scaling up their own microservice environments. They were dealing with this exact challenge. How do we empower our engineers to be able to troubleshoot and ultimately find and fix issues within these really complex distributed environments? And the solution they came up with was distributed tracing. Right, so here at Epsagon, we strongly believe that within these complex microservice environments, when you're working with all these APIs, the only way to really achieve observability is by combining metrics, logs, and traces, the three pillars of observability. Because as I mentioned, metrics tell us what, logs tell us why, but traces really tell us where, and they connect those other pieces back together in a really powerful and unified way. All right, when we talk about tracing, I think one of the big forces behind it becoming as popular as it has is really around the open telemetry framework. It is very much a framework. It is not a service, but it provides a standardized way to really create and propagate these traces. You've had a number of large technology companies come out with their own tools to help support this, Jaeger and Zipkin being two of the major sort of open source distributed tracing tools. But they do have some drawbacks, particularly around the sort of heavy lifting to set up this tracing. It's a lot of manual code changes, both to instrument and maintain on an ongoing basis. They also, at least for some of these open source tools, they lack things like visualizations. They lack context to those metrics and those logs. And they're going to have a really difficult time tracing through middleware pieces. And so what do I mean by that? It's very common in these new modern environments to have a scenario where you have a Lambda, your Lambda writes to Dynamo, that write then triggers another Lambda. Something like OpenTelemetry is going to have a really hard time connecting those pieces and really being able to trace through that Dynamo call. And so there still are some gaps with this open source tooling. Just to give you a little idea of what instrumentation looks like using something like OpenTelemetry, it is going to be a lot of manual code changes, going into your services, every service, and instrumenting all of these calls that you want to capture, whether that's AWS SDK, HTTP, Postgres, whatever it is you want to collect as part of that transaction has to be manually instrumented. You have to create those spans for every request and response, add context, right? If you want payload information, you have to include it and manually code that in. And then you also have to inject and extract IDs in all of these calls to really help stitch things back together after all of those transactions and requests have finished. All right, of course, in addition to the open source tooling that's out there, there are a number of sort of managed, hosted providers of this distributed tracing technology and this observability, of which Epsagon is one. We very much believe in sort of taking open tracing and the power there and building on top of it. That is to say, as opposed to manual instrumentation, you can instrument your applications instantly using Epsagon, whether those are Kubernetes, ECS, serverless, whatever the case may be. Out of the box, we correlate information like metrics, logs, and traces, so you understand really what's going on, and you really have that end-to-end observability throughout your application stack. All right, great. So we looked at our first example of troubleshooting distributed applications, largely in the context of traditional tools and logs and metrics. But now let's look at that again, and let's look at it from the perspective of distributed tracing. All right, and so when you have great tracing in place, what it allows you to do is not just have to look into your logs and do that searching and do that correlation. You're actually going to be able to have these traces, and these traces that are well visualized and allow you again to step through at each phase of this transaction and really get insight into what's going on. And that insight and that correlation is going to include things in Epsagon out of the box, like correlation to your stack trace, also the ability to see the logs associated just with a specific request, as well as provide that full payload information out of the box, really helpful for troubleshooting and for some other use cases, as we'll see in a little bit here. All right, and then in addition to traces, of course, that correlation, right? Logs are still very important for the why, but we want to do it in context. We want to allow you to click on show logs for a specific request and just see those log lines, because now we can very quickly dive in, see really the errors coming from an expired JWT, and now we know ultimately what we have to do as engineers to sort of go back and fix that. All right, and then of course, what we looked at is if you're sort of troubleshooting a targeted issue, right? You have a trace that failed and you want to investigate, but oftentimes it's equally important to have live tail tracing, live feed of all the traces being generated within your system. Particularly for examples where maybe you're about to do a big release, right? And you want to make very sure that when you release this new code for one of your services, it doesn't have any negative impact. Being able to see this live field of traces in real time is going to be extremely powerful. If something goes wrong, you can click into a trace, see that view we saw a little bit earlier, and start digging in to really troubleshoot and remediate that issue. All right, of course, you're going to want to be able to filter this down. And so here we're seeing all of the data from all of our services, all of our managed services, all of our middleware. Of course, we would have the ability to focus that down and say, maybe just show me all of the traces for Dynamo database, and maybe just show me all of the traces for one specific operation. So being able to really target and tailor the data that we want to be able to analyze and review. All right, and so above and beyond that, a good observability platform is really going to empower you to visualize your APIs and microservices. And so, what that's going to mean is not only providing that trace level data with that log correlation, but also give you other ways to understand what's going on within your application architecture, right? And so this is one part of what we call a service map here at Epsagon. You can see there are other parts of this larger application, but right now we're just focusing on one service because we see that it has a high error rate, right? And so just visually and by scrolling over this service, we have some really good insight into things like the metrics, what's the throughput, what are the latency between each of the pieces it talks to, as well as what is that error rate. And so this allows us to come in, really identify an issue, focus down, and understand things like what is that downstream impact, right? In this case, auth0 is a downstream impact, it's a dependency, and so that might be problematic, right? Users can't authenticate, that's not a great user experience, and so that's where we're gonna then dive into the traces to really understand, again, what that issue might be. All right, similar view, but this is, I should say, it's representing the same information. This is, again, looking at one business transaction. but it's allowing us to do it in a way that really highlights where is our code spending time throughout this whole business transaction. What does that look like? And so we have this, this flame graph or waterfall or timeline view, whatever you might call it. That's going to give you that great level of insight of knowing how long each piece is taking, knowing where time is being spent within your code, and also, again, having that full correlation to things like the payload data for each of these entities allows us to dive in and say, okay, this put item is taking 7.44 milliseconds. What exactly is the data there? Is there something we can optimize to help save time? Because that's important for our users, right? I mean, if you look at, I think Google did research that 40% of users will leave a website that doesn't load within 3 seconds. It's very important, both reputationally, as far as from a business context, to make sure that you've really optimized, and Epsagon's a tool that's going to really help and enable that process for you. All right, but a good tracing platform should also, not necessarily be limited to providing you technical measures and technical insights, but it should also provide or give you the ability to understand really interesting business insights, right? And why is that? That's because of that full payload visibility, right? For each request that we're collecting trace data for, we're also collecting the payload. And so you can pull interesting fields from any of those payloads, things like, for example, the quantity value within your Kafka cluster, because what that actually represents from a business standpoint is the total number of items that have been sold or ordered on this e-commerce platform. And so we get really interesting business insights as well. We had a customer expanding to a new market. They were able to very quickly set up visualizations and dashboards of the traffic for that specific market to understand how that rollout was going. Or maybe you just want to understand the overall user experience across a number of different applications that you are having observability into, right? Which of my applications across my entire empire is ultimately struggling or providing an experience that isn't what we would like. Right, and then, of course, really important, again, as it comes back to making sure your application is robust and providing that good user experience, is being able to get really good insights into your errors, but in a number of different ways, right? Whether that's trying to understand how that, the breakdown of errors by status code, whether that's trying to understand the breakdown of errors by exception type, or maybe it's even more tailored than that, right? Maybe you're pulling out a username payload field because you have a very important customer and you have SLAs. And so you want to visualize what is the average duration that one customer is seeing, or my top 5 customers. And so having that rich trace data, all of that metadata, all of that payload data is really what's going to allow you to ultimately visualize and understand what's going on within your architecture and for your APIs. All right, great. So in summary, distributed applications bring unique benefits and challenges. As we've discussed, it's really great for things like developer velocity and rolling out new features, but it's really challenging shooting. And so, at least in our experience and our customers' experience, API and microservice observability is absolutely critical to both keep track of your architecture, understand what's going on as you scale up, but also to detect performance issues and then be able to troubleshoot those either through traces, and then with those traces correlated to your logs and your metrics. All right, we'll have a QA in just a second here. If you do have any questions, feel free to drop those into chat. Otherwise, thank you so much for coming. Please feel free to check out Epsagon, reach out to me if you have any questions, as well as check out our special offer for all attendees of Developer Week at epsagon.com/developerweek. Thank you.